All right, new chapter. We're going to start off with systems of equations, which means we're going to have systems, meaning two or more equations, and we're going to see how they interact on the same coordinate plane. In other words, I'm going to graph two things on one plane and see how it works out. Normally, we put one graph per plane. So when I look at this, one possibility, and we're going to keep these as lines. Remember in math that all lines are straight. Okay, there's no such thing as a curvy line in math. Okay, so one of the ways that they can interact with each other is I could just have them randomly cross, which means that they will share one point. So this line has an infinite number of xy coordinates, and this line has an infinite number of xy coordinates. Well, they're going to share one of them, which means the xy coordinate will work in both equations because they share it, okay? So there would be one solution, and it would be an xy coordinate. Another way for two lines to interact in the same coordinate plane is for them to be parallel, okay? In this case, so if this one has one solution, because they hit at one point and it's an xy coordinate, how many solutions is this going to have? This won't have any. Okay, this will have no solutions because there is not a point that they share. There's not a point that has the same xy coordinate for both of them. Okay, they never hit each other. The other option is kind of weird. Okay, so let's draw that line, and then let's draw this line. Okay, so I just drew two lines. Physically or geometrically, you cannot see that there are two lines here. I drew them. One was black, one was purple. Okay, but you really can't look at that and say, hey, look, there's two lines, because they share an infinite number of solutions. Okay, an infinite number of solutions, because there's actually, when we look at the equations, there'll be two equations, but they'll end up settling down once we work with it a little bit. They'll be the same answer. They'll be the same equation. Infinite number of solutions, okay? Now, how can we do this? We have a few different ways that we can solve these things. Way number one, which is our least favorite way, is graphing. Okay? Well, I just drew you three pictures. Okay? If they hit at the same point, I can look at that point, tell you the coordinates of it, and now we're done. Okay? I can look at these and say, oh, look, they're parallel. There's no solutions. And I could look at this, and if I told you that there was two equations, you would say, oh, it's the same line. So there's an infinite number of xy coordinates that they'll share. This really is only pretty if they cross on a grid mark, okay? So if they cross on a grid mark that I can read easily, well, then it's easy enough to use a graph. But how often does that happen? All right, so number two is I can use elimination. And this is actually my personal preferred way to do it, because we end up killing a variable and solving for the other one. The third way to do it is substitution. Okay, and I'm going to go over all of these when we start practicing, because we're just going to dive straight into practicing. Okay, substitution, if it's set up for it, is easier. But if it's not set up for it, then you have to do a whole bunch of rearranging just to substitute and do more rearranging, which is scary. Okay, so bottom line is, as long as you do one of those three and you do it correctly, I'm not going to know which method you used because you'll get the right answer. Okay, so I won't know what method you used. So you use the method that you prefer. I don't care what the instructions say. You use the method that you prefer. All right, so we are going to dive straight in, and we are going to learn how to solve these things. Okay, so minimize. All right, so the first thing is determine whether the given ordered pair is a solution of the system of equations. So you have a curly bracket, which you're supposed to have, and then you've got a negative x plus y is a negative 6. And then your other equation is a 2x plus a y is a 15. And I want to know if the point 7, 1 satisfies both of those. So the curly bracket says this is a package deal. Okay. The top one is a line. Okay, the bottom one is a line. How do we know? Because there's x's and y's, and the biggest degree is 1. There's no squares, there's no cubes, there's no weird stuff. Okay, I want to know if this point is a solution of both of them. So if I'm given an x and I'm given a y, I can test it in both of them. So the top equation says negative, and then what's my x? 7. Plus y, what's my y? Is 1. And that should be negative 6. Okay, negative x, which is 7. So negative 7 plus y, which is 1, should be negative 6. Well, what is negative 7 plus 1? It's negative 6. So that point is on this line. Now the next question is it on this line? So we're going to try that one. So I have 2x, which instead of x, I'm going to put a 7, plus y, which I'm going to put a 1, needs to be 15. Okay, what is 2 times 7? It is 14. What is 14 plus 1? It is 15. So this point worked on both of them because 14 plus 1 is 15. Okay, so this is a solution for this system of equations. So your answer is simply yes, because it works in both of them. Okay, so now we're going to try another one. So what we have is this. My system, which is supposed to have a curly bracket, is 7x plus 9y is negative 65. And 4x minus y is going to be 12. Okay, so we're going to talk about this just a little bit. Would you please notice that you have an x column, a y column equals your answers. So you've got x's, y's equals answers. Okay, that's going to be extremely important in the future because we got to set these things up in a different format. But for right now, the instructions say to use substitution because y is almost by itself. I don't want to use substitution. I want to use elimination. Okay, so looking at this, if I wanted to kill my x's, they would have to have the same coefficient, but one would be positive and one would be negative. Okay, so killing x's is not really on the horizon right now. Let's look at killing y's. I need to kill y's. They need to have the same coefficient. One is positive and one is negative. Well, this one has a positive 9. This one has a negative, but he needs a 9. Okay, so remember, I can do anything I want to as long as I do it to the entire equation. So what this says is I'm going to take 9 times row 2. So this is row 1, this is row 2. Okay, so I'm going to take 9 times 4x, 9 times negative y, and 9 times 12. So I'm doing it to that entire equation, so it's valid. I'm allowed to do that. So what that makes now is a 7x plus a 9y is a negative 65, and now 9 times that bottom row. What is 9 times 4? 9 times 4 is 36 x's. What is 9 times negative y? It's a negative 9y. What is 9 times 12? Holy cow. 9 times 12 is 98. Okay? 9 times, let me make sure that's right. 9 times 12 is, hang on. Someday I'm going to have a calculator. It's 108. That would have been a travesty. All right, 108. I knew that didn't sound right. All right, so it's 108. Okay, so this is the point of elimination. I'm going to work vertically. So what is 36 plus 7? 36 plus 7 is 43 x's. Okay? What is 9y's minus 9y's? There are no y's. You have eliminated your y's. Okay? And then what's 108 minus 65? 108 minus 65 happens to be 43. So if this is all I gave you, pardon my sparkle foam. Okay, if this is all I gave you, could you solve for x? This says 43 times x. So to separate it, you have to use division. So I'm going to divide both sides by 43. Any number divided by itself is 1, so that leaves me with an x. Any number divided by itself is 1, so I get x is 1. Well, now that you know what x is, you should be able to find out what y is. And remember that this coordinate, so like up here it was 7, 1, it worked in both of them. Okay, well, I have an x coordinate, it will work in both of them, and it will give me the same y coordinate, whichever one I use. So I'm looking at the bottom row. To me, that looks a little bit friendlier. The top row has larger numbers. It's really not a big deal, but the top row has larger numbers, so I'm going to use the bottom row, and we're going to find out what y is. So now I have a 4x minus y is 12, but I happen to know what x is. So 4 times 1 minus y is 12. So that gives me 4 minus y is 12. So I'm going to subtract 4. So negative y, 12 minus 4 is 8. Okay, so I subtracted 4 from both sides. And now negative y is positive 8, which means divide both sides by negative 1, and you get y is negative 8. So you have a coordinate of 1, negative 8. And that will work in both of these equations. So if you were to graph these two lines on the same coordinate plane, they would hit at 1, negative 8. Okay, let's do another one. So we have, the instructions are to use substitution. I say, you can't make me. So 2x's minus 5y's equals 9. And then I've got negative 6x's plus y is negative 5. Okay, so if I look to kill off my x's, I need the coefficients to match, except for one's positive, one's negative. If this was a 6, then this would be negative 6 and they would go away. So if I multiply that by 3, I'll get my 6. Okay, if you don't want to kill the x's and kill the y's. One of them's already positive and negative. If this one had a 5, then I could kill my y's, because negative 5 plus 5 is 0. Okay, so I'm going to choose to kill my x's simply because we killed the y's last time. So what do I need? This is a negative 6. I need him to be as positive 6. So what do I multiply this row by? Simply so I can force him to be a 6. My top row needs to be multiplied by 3. Okay, so that will generate my 6 right here. So 3 times row 1. What that means is I now have 3 times everything up here. 3 times 2x is 6x. 3 times negative 5y is negative 15y. 3 times 9 is 27. Okay, rewrite the bottom row. The bottom row says a negative 6x plus y is a negative 5. And now I can solve. Because working vertically, my x's are gone. 6x's minus 6x's is no x's. Negative 15y's plus a y is a negative 14y's. 27 minus 5, this is ugly. Okay, 27 minus 5 is going to be 22. Okay, so now when I go through and solve this thing, I have, I'm checking to make sure I didn't mess you up. All right, I didn't. Divide both sides by negative 14. So any number divided by itself is 1. So y is going to be negative. I can reduce both of these by 2. So I get 11/7. All right, so we just slammed into fraction world, which is fine, because now we're going to grab either equation to find out what y is. So I'm going to go ahead and find out what, I'm going to use the top one. It looks a little bit friendlier. So I have a 2x minus a 5 times y. Well, y is negative 11/7 equals 9. So that gives me 2x's plus 55/7 is 9. Nobody wants to work in fraction world, so I can multiply everything by 7. So I'm going to multiply this term by 7, this term by 7, so it'll reduce, and this term by 7. Okay, so that gives me 14x's plus 55 equals 63. Okay, and I just did that to get me out of fraction world. If you want to subtract 55/7 from both sides, you go right ahead. So I'm going to subtract 55. Okay, so 14x's equals 63 minus 55 is 8. Okay, why is my mind blanking? Yes, it's 8. Good heavens. All right, divide both sides by 14, and I get x equals, this reduces by 2's, so I'm going to get a 4/7. So my answer, put this in order because we found y first. My x coordinate is 4/7. my y coordinate is negative 11 sevenths. It has to be in order. Okay? And we'll see you on the next video.